Hello, my name's Stefan. Today I'll be talking about property tables. So property tables are an important tool in thermodynamics that allows to easily find certain intensive properties for a substance when either the temperature or the pressure is known. Um, and typically the most common uh, properties we see on a property table include specific volume, internal energy, enthalpy, and entropy. And what's important to keep in mind is that all of these are intensive, so they're properties over unit mass, right? So meters cubed over a kilogram, kilojoules over a kilogram, etc. Um, and for these types of questions, we usually assume that we're dealing with a saturated mixture until we can prove otherwise. So typically, we first start with the mixture tables, with the saturated mixture tables. And then once we determine that it's not a saturated mixture, we can go to either a superheated vapor table or a condensed liquid table. Um, so we have two types of saturated mixture tables, a temperature table and a pressure table. And the reason why is because in the saturated mixture region, um, temperature and pressure are not independent of each other. So um, this means that we can only take one or the other uh, and find all the other intensive properties using one or the other. Typically, in a question, you'll be given one or the other, not both. So um, if you're given, for example, temperature in a question, then resort to using the temperature table. And similarly, if you're given pressure, use the pressure table. Um, Now, you'll see below the properties that um, we have a saturated liquid and saturated vapor. So saturated liquid is the lower extreme of the saturated mixture, and a saturated vapor is the upper extreme of a saturated mixture, right? So anything in between is a liquid vapor mixture. So all the properties for a saturated liquid have a subscript F, and all of the properties for a saturated vapor have the subscript G. Um, Now, in many cases, we're not dealing with pure saturated liquid or a saturated vapor, but we're dealing with a liquid vapor mixture or something in between a saturated liquid and a saturated vapor. So in that case, we have to introduce a new property called quality. And quality is represented by the symbol X. So X ranges between 0 and 1 in the saturated mixture region. And 0 tells us that we're dealing with a saturated liquid, and 1 tells us that we're dealing with a saturated vapor, and anything in between is a liquid vapor mixture, right? So quality is essentially the ratio of the mass of the vapor to the total mass of the substance.
Hello, my name is Maxen Deck, and today I will be talking to you about the superheated vapor tables. So basically, there's a selection of temperatures and pressures, and when you have a temperature that corresponds to a particular pressure, you can find other properties of your vapor, such as the specific volume, specific energy, specific enthalpy, and specific entropy. And basically, when you have a certain temperature and a certain pressure, you can find those other properties that will help you solve the problem that you're doing. So, for example, if you have, say, 300 degrees Celsius and zero point 0.3 megapascals, your specific volume would be 0.8753. And this is really useful if you're trying to find, say, the difference in specific volume between two states, or if you want to know the specific entropy of one particular combination of temperature and pressure. So this is obviously going to be a very, very useful tool for whenever you are solving a problem that has different properties for your vapor.
Hey guys, my name is Cosmas Markatos, and I will be presenting you the compressed liquid water table. Let's begin with identifying a compressed liquid. Note, a substance is considered to be a compressed liquid when the pressure is greater than the saturation pressure for a given temperature. As you can see, the table begins at 5 megapascals and increases each section. Just like most thermodynamic tables, at the top of the table we have columns for different parameters. Those parameters are specific volume, internal energy, enthalpy, and entropy. Since the table begins at 5 megapascals, for any pressure below 5 megapascals, we must use the saturated liquid table, as they are approximately the same at the same temperature. Another important note is that enthalpy is more sensitive to changes in pressure. Because of that, at high pressures, the enthalpy can be calculated by using the following equation. And that's it. Thank you, guys.